All right. Welcome back. Let's see. Right. Yeah, in our last lecture, we had introduced the fact that we had reached the second half of the semester, and that we were going to focus our attention to the building of a server, right? That we were building web applications based on the client server architecture, and that our first half of the semester focused on implementing the front end, the client, right, the client side of the client server architecture. And yeah, in our last lecture, we discussed several skills, right, on how to set up a server, how to communicate between the client and the server, how to integrate, how to pass data around, right, how to do asynchronous communication. So this time around, we're going to be discussing how to use all those skills that we discussed in our prior lecture, right, to implement, right, a server for our ongoing Kambaz application. Right now, our Kambaz application is just mostly just a front end, right? And we've reached the limits of what you can do just with the front end. So we'll be adding a server to the web application. Okay. Right. So we're going to be focusing on implementing an API, right, to integrate the client server, the both sides of our application. Right. We've been focusing mostly, up to this point on the client side, right, using technologies like HTML, CSS, TypeScript, React.js running on a Next.js framework, and there's some limits of what you can do just with the front end. Right? Because we are running inside of a browser. Right? We don't have access to the file system. We have very limited access to the network. But certainly there's some upsides, right? We can interact with the user. Right? We can respond to user input as a click and drag and type at the keyboard. We can consume that content. We can also render content for the user using HTML, CSS, and JavaScript. Right, we can draw stuff on the screen and create content for them dynamically. But any modifications we do on the user interface are very temporary. They only live within the session of the client. Right, so if you refresh the screen, it all goes away. So if we, when we were adding courses or modules or assignments in the Kambaz application, if you refresh the screen, all those went away. So what we're going to do is that taking what we've learned in the last lecture, right, we're going to create an API here on the server. Right? The server will be a process that runs outside of the browser, so it won't have any of the limitations of the browser. Right? It will have full access to the operating system and the file system. It will have access to a database, right? And it'll have unrestricted access to the network, right? So we'll be able to integrate it with all sorts of other services out there, right? And so just like we used Node.js for implementing the front end, right, where React.js is a JavaScript library that runs inside of the browser. Right now, we're going to have Node.js running outside of the browser. That using the Express library, right, to implement these web APIs so that we can integrate with the front end. And we'll have the front end send asynchronous queries out to the server, so that the server can do work on behalf of the user interface. So instead of maintaining the state of what courses, what modules we have, instead of maintaining that on the client, on the browser, instead we'll maintain it on the server. The server will maintain the application state, so it will not be subject to the limitations of the client. If you refresh the browser, we lose all that, but the server can still maintain that state. We can always go back to the server and retrieve that information. So first, we'll need to move the database, right? Quote unquote, the database. And our implementation on the client was just a whole bunch of JSON files that we collected into one big JSON object, right? And we called it the database. It's not really a database, obviously. It's just one big object containing, the data structure for the application, or at least the initial state. And so now, in reality, the database should live in the database, right? In a completely separate process, right? That we would integrate with the server. But we don't have a database yet. We'll talk about the database earnestly starting next lecture. Meanwhile, what we'll do is that we'll bring over all those JSON files, and we'll bring them over to the server and implement more or less what we already have in the client, but it'll be on the server. And but we won't suffer as much what was happening on the client, where if you refresh the screen, you lost all your changes to the data structures. Here, we have a little bit more leeway what we can do, right? At a minimum, we're going to load this this quote unquote database onto the memory of the server, so that if the client crashes or needs to refresh, it can always come back to a server to retrieve any of these data structures, right? Including any changes that we might have made to the in-memory copies, right, of these users or courses or modules. We'll be appending to these arrays, right? We'll be modifying these arrays all in memory and on the server's memory. So even if the client refreshes, it could always come back and retrieve the latest copy of the courses, having added or removed courses or modules and whatnot. I mean, obviously, it's not going to be entirely persistent, right? Because if the server crashes or restarts, this data structure is going to be reloaded brand new. I mean, we could have the server that has access to the file system. It could write to these files, right, and append directly to these files. But I mean, if we're going to do that, might as well go to a database, to an actual database, and that's what we're going to do next lecture, right? This time around, we're going to be practicing, how do you manage the state on the server, and how do you integrate, right, with the user interface. And we'll get started on some of the design patterns on manipulating this data, right? But eventually, all this is going to be in the database, right? Starting next lecture. So let's demo this. How would we do that? Currently, the database lives on the client, right, on our React client, and it consists of several JSON files. So we're going to just copy these JSON files, and we're going to move them over to the server. So on the server, right, we have a database here. We're going to just paste these files in here. We already have courses, but it's right now I didn't put anything in there. Let's just paste these files. These are JSON files. I mean, we could leave them as JSON files, but it'll be more convenient if we convert them into their JavaScript equivalents. So I'm just going to remove these .json extensions, and we're going to change it to .js. And we'll convert them into JavaScript objects instead of just JSON objects. We'll have to massage them just a little bit, but not much, right? Almost imperceptible. So let's do that. And then finally, the user. And then now in JSON, the syntax is that the properties, right, and the values need to be quoted, right? Especially if they're strings, right? well, I mean, the values could be any data type, certainly strings, could be numbers, booleans, and so on. But also the properties themselves have to be quoted, but not in JavaScript. In JavaScript, it's redundant, for you to use. I mean, you can quote them, but it's not necessary. So if you save these, notice that your IDE will automatically remove the double quotes. And we're going to export this so that we can easily import them from outside, so we can share them. Let's save that. Notice that it removes the quotations. And let's do them for all of these. Let's save that and then export default. And let's do it for all these. Assignment, courses, enrollments, modules. There we go. And users. And very much like we did in our user interface, we'll create an index to grab them all and put them all in one single place, right? We'll create a big object that collects them all, right? Import them all. So we can just copy this and let's paste that in here. So this is just importing them all, right? And building one big object, and then it's exporting it so that you can just import this whole object, okay? All right. All right, so we have the quote unquote database in our server. So, okay, so what we're going to do is that we're going to create web apps, web APIs, right, to be able to interact with these data structures. Now these data structures exist in the on the server, right? Here's the server, and now the database lives here that has several arrays of users, courses, but they need to be accessed by the client, right? The client wants to display the currently logged in user, or wants to display courses or modules here in the user interface. So somehow the client needs to go out to the server, fetch the data, and then get back a response with that data. In particular here, let's discuss the integration that we would need for being able to sign in, sign up, all the account related tasks, right? That you first maybe sign up to create an account, and then sign in, right, to identify yourself with the application. Then we might need to retrieve the profile, right? Who's a currently logged in user, and at some point we'll need to sign out. So these are all actions that are initiated by the user, right? Here's the human user as they interact with any of the pages, right, inside of the account, right? And so they'll either click on the sign in button, or the sign up button, or on the sign out button, and so on. Okay. So what we'll do is that we'll have a couple of dedicated files, right, on either end of the client and the server, that know how to talk to one another through HTTP, right? That the client will be able to send HTTP requests, either get, post, put, delete, that are going to go out to the server that's running locally at localhost 4000, and it's gonna encode the URLs, various types of URLs, for various commands, whether we're signing in, signing up, retrieving the profile, or signing out. And they're all going to start with /API/users. And that's a very common way to format these paths, right? To start off with /API, kind of to denote that we are going out to the server not for visual content. Like we're not looking for HTTP or HTML or CSS content. We are communicating with the server specifically for interacting with behavior or functions that are implemented on the server. Right? So API is a very common token, right, to prepend the URL, right, to make it clear that we're not looking for human content. We're looking for content or interactions with between programs, right? That's why it's an application program interface, right? So it's an interface for programs to talk to one another. And we'll follow the best practices that of using the convention that we'll use HTTP GET for retrieving data, HTTP POST for creating new data, HTTP PUT for updating data, and delete for removing data, right? So that's a convention that we refer to as the RESTful Web APIs convention. Another convention is that if we're interacting with a specific type of data structure, like if we're interacting with users or courses or modules and whatnot, right? We will use plural nouns, right, to specify the subset of data structures that we are interacting with or that we're operating on. So here it starts with API users, indicating that we are going to be creating or deleting or updating, right, or retrieving users. Okay, and there's going to be several operations here, typically for sign in, sign up, and whatnot, right? So these two, right, the client file on the UI side, on the client side, is going to have all the communication code, right, to talk to the server. Whereas in the server, we're gonna be defining several routes, right, that are going to be ready to receive those requests, right, from the browser, from the client, and they're going to call functions. They're going to pattern match these URLs, these methods, these paths, right? And based on that, is going to call several functions that are going to implement those actions, right? Either calling functions locally like sign in, sign out, and whatnot. So these two are both sides of the integration layer between these two processes, right? Now, the actual manipulation of the data structure will be done by DAO objects or data access objects, right? That, like the name suggests, right? They implement the design pattern of data access layer, right? They're the ones who do the actual work of adding or removing or creating the data, and they're going to be using, right, they're going to be manipulating the data that is in the database, right, through several functions, right, that are going to be implemented in the DAO to create a user or find a user in various formats, find them by username or by their primary key, and also various CRUD operations, creating, reading, updating, and deleting these users. And all these are going to be coming back, right, to the client, with a response, right, depending on which way we went. Okay. All right. So let's just start implementing this, and we're going to work our way from right to left, where we'll work first on the DAOs, and then work our way to the routes, the client, and then the user interface. Right. So from lowest level, right, of actually manipulating the data, we work our way up the chain to where the process starts, right, when the user initiates the task. So let's look at the user DAO first. So user DAO is going to be responsible for manipulating stuff in the database, right? And so it's going to take us an argument, a reference to the database, and we're going to be able to get a hold of an instance of the database so that we can retrieve the specific data structure that we want to manipulate. So for instance, here we have a function that, given an instance to a new user, we can append that new user at the end of the array of users. And since this is a reference to the user's data structure in the database, this is available, throughout our application. Anybody who has a reference to the database has access to the new array of users. And creating users, the code is very, very familiar, right? Very similar to what we would do anyway in the front end, right? We would create a new instance, append maybe the objects that come in the user, including username, password, first name, last name, whatever data we already have coming in from the user interface. And then we would create a primary key instance using the UUID library, the same library that we've used in the client. We're going to install it also here on the server. And once we have a instance of a primary key, we then are going to append it to the array of users. Now, this is a very common practice, right, that the primary key is created, here on the server, or even better in the database, but not necessarily in the user interface. The way we were doing it so far, of creating the primary key in the user interface, not really realistic. It's more likely that it's being created either on the database side, right, or the server side. So let's copy this and create a new users DAO. So here in our Kambaz, we'll create a users DAO, and let's initialize it. I don't believe we have the UUID library installed, so we have to remember to install it. So we'll have all the operations that we would need to manipulate the data structure, including being able to create new users, and what else? We'll need to be able to retrieve users in all sorts of ways. We can either retrieve all the users, all the instances, meaning the entire array, or retrieving an individual user if we know their primary key. Also, a common operation is we'd like to know if a particular user with a particular username exists, right? For instance, when we are signing up and we're registering as a new user, we want to make sure that this username doesn't already exist. So we need to go look it up to see if it does already, so that we don't duplicate the username. Another one is that we want to retrieve a particular user with the combination of their credentials, their username and password. Again, this is useful when we're logging in. Does a user with those credentials exist, right? So that we can log them in. So let's copy that, right, and paste them into our DAO. And then finally, we'll need operations to to update an individual user, right? We'll need their primary key and the updates, right? Whatever, whenever new fields we are modifying, and then finally delete that user if you give us their primary key, right? So let's copy that and let's paste that in there. Right. So this user DAO will take the argument of the database and has defined all sorts of operations to be able to manipulate the data structure in the database, a particular data structure, and it's going to send back, right, a reference to all these functions. So whoever calls this is going to receive a reference to all these functions so that they can call it from wherever we are being instantiated. So let's not forget that we'll need to install this library. So let's make sure we do that. We'll go to the server, stop for a second, and npm install UUID, and we'll restart the server. Okay, so once we have that, once we have the DAO, so we're here, right? We implement the DAO that knows how to manipulate the data structure. We now have to implement the interface, right? That is going to be invoked by the user interface that is actually going to use the DAO, right, to interact with the user interface, right? So yeah, so let's create a routes file that this is going to be the interface, right, for the user interface, right, to call. All right, so let's create here a routes file, and so let's copy this here. So what we'll do is that we'll load up, import the DAO, and then we'll keep track of the current user. Right now, we're keeping track of that in a reducer in the user interface. and it works okay, except that if we refresh the screen, we lose a reference, the value of who is currently logged in. So instead, we're going to keep track of that on the server. The server, even the browser refreshes, will still have a copy of that here. The user route is going to define several web APIs, right, that can be invoked from the user interface. So we'll need a reference to the app, right? That's the Express instance, and also a reference to the database because we're going to pass it down to the DAO. And to implement all our tasks, right, all our functions, we'll need a reference to the DAO, right, based on the database that we are receiving as an argument. Now, these are all the functions that we're going to be implementing, right? So here's just a copy of them. Now, I'm keeping them categorized. This is a set of functions that are going to allow us to do all the CRUD operations, the creating, deleting, updating, right? And they're not implemented just yet, right? So we're gonna leave them undefined for now, right? We'll come back to them a little bit later, but these are the functions. We have to fill in the blanks of their actual implementation. But I did want to point out the API, right? The API is basically, these are the routes, right, that we're going to be sending post or get or put or delete, right, to either create a new user. We're going to post is for creating, and the new user will be included in the body of the request. Find all users, right, it's a get. Notice that it's the same URL, but the server can distinguish them because one is a post and the other one is a get. That's how they're distinguished. For updating, right, we're going to be using put, right, for manipulating, replacing data for a user, and deleting. We'll notice that for these three, we do need to provide the primary key of the user that we are interacting with. Either I'm retrieving a single user, I'm updating a single user, or I'm deleting a single user. Okay. The other set of functions that we are interested in, right, are the kind of like the authentication or the credentials or the account related functions, right, where we can register a new account, identify ourselves later, look at our current profile, and finally sign out. Okay. And so these are the URLs or the web API that the client is going to use. Now notice that for all of them, I'm using post. Okay. And I just a minute ago I said that post is typically for creating new users. And while that is true for sign up, right? For sign up, usually we're going to insert a new user to the database. So post seems to be appropriate. The other one, sign in is not necessarily creating a new user, right? It's not inserting anything in the database. So you might say, well, why are we even using post, right? Doesn't that break the best practice? Also notice here that we're using verbs, right? And yes, that is true. We're somewhat breaking the best practice, but here it's worth it, right? Because it's not a regular CRUD operations where you are, creating, reading, updating, deleting. These are specific for one specific task of identifying yourself, creating a profile, retrieving a profile, and the safest for interacting with security, with anything that has to do that might compromise security, is to use post, because whereas get, right, the URLs are in the clear, right, any security question or any security concerns, it's best to be handled with post, because post can, first of all, we can use HTTPS, right, that can encrypt, but also most of the data is going to be sent over in the body, right, in the body of the request, and only only post and put can do that, right? Where we can include in the body the data, including the our username and password if we're signing in or signing up, and the body can be encrypted so that even if somebody's listening in between the browser and the target server, right? They won't be able to steal our identity, right? So post is the most secure. So that's why we're using post for all these credential sensitive information kind of operations. Yeah. Okay, so we have the routes. We do need to import these into our root server, right? We'll need to import them, import our user routes. There it is. And we're going to pass it, app.db. We need DB though. We need to import the database. So let's import DB from index. And we're passing it down here. Perfect. Okay. And let's see, the server should have restarted. Okay, perfect. All right, so now the user routes has a reference to app and the database. Okay, so that concludes the setup of the client code. We do need to start setting up the front end as well. And we're going to start implementing each one of these operations. So let's take a look at sign in first. So for sign in, right, it's going to look like this diagram, right? These are the sequence diagram of signing in, right? The user is going to navigate to a sign in screen, right? The sign in page, and they're going to fill out, their credentials, their username and password, and they're going to type in sign in. So that sign in is going to invoke a sign in function in our client, which is going to generate a post. It's going to send a post, localhost 4000 API users sign in. And in the body of that post is going to send the credentials, right? The username and password are going to be embedded in the body. The routes is going to receive that request and going to parse out the username and password. And it's going to first go ahead and go to the server, to the DAO, right? And retrieve to see if the user exists or not, okay? Right, it's going to check to see that, does the user exist? If not, then what we'll do is that the other thing that needs to do, that's not listed here, is to create the user if the user does not exist. So this would be, actually, no, that would be for the sign up, right? For signing, it's just going to check to see if the user exists, comparing their username and password. Now, for that, it's going to iterate over the users array, right, using find, checking to see if there's an object in the array that has those username and password. If it does find it, it could be that it doesn't find it, so it's null. But that information is what's going to go back to the response, either a user that was found in the quote unquote database or null. And depending on whether we do have user or null, it'll either stay in the sign in page or navigate to the dashboard. Okay, so yeah, so let's implement that in the DAO. Right, we'll need a find user by credential, which is basically just a simple find. Right, so find user by credential, and there it is. Right, it's already implemented. We have the users array, right, that it takes from the database, and it iterates looking for a pattern match against username and password. If it finds it, it returns the object. Otherwise, it returns undefined. Okay. And so now this particular function is going to be invoked, by the route, when we send a post to the sign in. We're gonna send a post, right, to sign in. In the body, we'll have the the username and password, so we can extract the username and password from the body, and then pass those credentials down to the DAO find user by credential. And then we'll assign it to our local current user. Remember that our routes, right, are keeping track of the current user, right? Which again, it could be null or an actual user, and then we'll send it back to the browser, right? So let's implement that. If we copy that in the routes here in the sign in, there we go, right? It's going to parse the username and password and pass it on to the find by credentials. So we find it, we store it locally. We now this would not be null anymore. It'll be an actual user, and we're going to send it out to the browser. Now the browser needs to be able to send this request, this post, and we'll do that from our client account client.tsts here. This one, account client.ts. Which is going to use the Axios library to send a request to the user's API. It's going to send a post that is going to include in the body the credentials, right? The username and password. And when it comes back, we'll respond with data which should be, the user object or null. Okay. So let's create these the client file. Right, and the client, here we have account, and we'll create a client file and paste it in here. So basically it's extracting the environment variable, the HTTP server, and it's creating this template for the URLs that go out to the server. They all start with HTTP localhost 4000 blah 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 /API /users, right? And then we append to that either sign in or sign up or profile or sign out, right? And then we're going to send in the body, we'll pass in the the object, which is going to be converted into a string that will be parsed by the server, right, to reconstruct the object, right? Now what we're going to do is that we're going to invoke the sign in from our page, right, which we have here. Sign in right here, we have the page. Right now, we do have an implementation that is using the local database, but the database is no longer here, right? We're going to comment out any references to the local database. Instead, we want to use the database on the server. And so for that, we're going to have to import the client. Import star as client from, to go up one, maybe another one. Nope. Client. Oh, there we go. Client. And in there we have the function sign in there. See that? So instead of using this, right, we'll have to convert this into async because all this communication are going to be asynchronous. This instead is going to do credentials. There we go. It's going to go out to the server using the sign in, pass in the credentials, and it'll come back with user either null or an actual user. Okay. All right. So yeah, so that should work. That just like that. And so let's see if we can demonstrate this. We should be able to see the network that goes out to the server when we sign in. For instance, if this is a bogus sign in and we sign in, the sign in object, the response, there's no response, right? But instead, if we use an actual user, right, we say Ada, with the password, and we sign in, notice that this time around we do get a response, right? There's Ada, right? Her ID, even her password. So that's dangerous, right? We have to make sure that from the server we never get a password back here in the client, right? So we need to cleanse that, right? But yeah, I mean, we do get an object back, and we successfully navigate to the dashboard, right? Now, notice that if I refresh, right, the user doesn't exist anymore, and I get a null on the current user because if it's undefined now, right? Because we refreshed, all that information is gone. We would have to re-sign in. So yeah, we still can't survive a refresh, but we'll fix that in a minute. All right. All right, so let's talk about sign up, right? So for sign up, the sequence of events would be that we would navigate to the sign up page. We would fill out our credentials, again, username and password, and we would click on the sign up button, and the sign up would collect the username and password and use the sign up function in the client, right? It would send a post right to the sign up URL, including in the body the username and password that we are signing up with, and then when it gets to the route, right, the route would use these two functions in the DAO. First one is to see if there's already a user with that username, right? If there is already a user with a username, right, we're going to abort this, send back an error saying, hey, that username is already taken. And so we would not navigate to the dashboard. Now, if the user does not exist, right, if the username is not there, we will create a new user, using the data that you're sending us from the body, right, the username and password from the body, and then we would push this new object into the user's array, and the new user would go back and we would navigate to a dashboard. Okay, so yeah, so for the DAO side, right, that is manipulating the data structure, we need two functions, right? One is going to create the user, right? We saw that earlier, right? We're going to get an object user from the user interface. The user interface is where you have the form, we fill out your credentials, and that is going to come through the request up to us, as an object, and we're going to use that, to append a brand new user. We're going to create a new user, right? There's the object with a new user with a new primary key. So that's how we, append or add to a new user. Now, we're also going to first check to see if the user exists. So we don't create a user if a username is already taken. So for that, we'll implement find user by username, which is going to iterate over the array of users, looking to see if there is a user with that username. If there is, then we won't create the user. Okay. For the route, we're going to have the wait a minute. For the route, we're going to be listening for incoming posts to API users sign up. The body is going to contain the credentials, right? And so what we'll do is that from the body, we can extract the username and use our new function in the DAO to find the user by username. And we're going to check, right, if it's user, meaning if it's defined, if it's not null, right, if it's truthy, we're going to respond with an error saying, sorry, that username is already taken. That user already exists with that username. And this is important that we return, right? We return because we don't want to fall down here, right, and actually create the user again, right, and do a second response. So we're going to respond right here and return so that, right, we don't have a second response. Now, if the user doesn't exist and user is undefined or null, then we do insert the new user with the new body, and in the create user, we are creating a new instance for the primary key, right? And we return a reference to that user, and we update our local current user, right? So let's copy that, and in our router for sign up, let's paste that in there. For the user interface, we'll have the client, where we're here, right, in the client, which is going to talk to the route. that is going to send the post with the user credentials, right? And the post goes out to the sign up URL. So let's copy that and put that in the client in the user interface. With sign in, we have sign up, and then we'll have a screen, right? The sign up screen. However you implemented it. I don't believe I asked you to implement it in connected to the route to a reducer or anything. So it's implemented here. We have a sign up page. Let's see. Okay, we have the sign up. We have the page. We have the page. So let me just copy this content and then we can talk about it. And here, let's copy that. And finally, this last piece. Let's talk about this. Oh, return. Oh, what am I missing? User. Oh, I have this twice. Okay, so yeah, so we are interacting with the reducer, right? Once we create the user, but locally we have a state variable that we can type in our username and password. Right, so it's connected to these two form elements that allow me to edit the username and password. The only real difference between these two input fields is that the second one is a type password, so you can't see as I type the password. But other than that, they're just editing this object, right? The username and password. Now, when I click on sign up, right, it's going to use this async function to call the client sign up, which is going to do a post and send over the user in the body. And now I can get back an error here. The username is already taken, or an actual user that has been added to the database, right? Now, obviously, this code does not consider the error message. Later on in the book, I do ask you to practice dealing with errors, right? Notifying them that what went wrong and whatnot. But here we are, considering that it's all good, right? The happy path, right? The ideal case. The user is brand new, and we set the current user in the reducer so that the current user is accessible throughout the application, right? And then we redirect to profile, right? Yeah. So if we try that out, right, and we sign up with say KWE, we do sign up. All right, it wants to go to the profile, which we don't have, right? Okay, so which is the next topic. Let's talk about the profile. Now when we sign up or sign in both cases, presumably we have identified ourselves, right? We know who you are, either because you signed up before or you just signed up and then now you're identifying yourself. In any case, we want to have that information available throughout the application, right? So it makes sense to declare the this information available throughout all the pages in the application, and we have the reducer for that, right? The reducer does give us access to information globally, and we already set that up, right? The difference here is that what we want to be able to handle is that say I log in, and the server knows that I logged in, so the server remembers that I have logged in, and say I come back to tomorrow, and the server as far as the server is concerned, right, I never left, right? So it could be the case that the server does remember me, even though the browser might not, because I might have either closed the browser. So at some point I need to be able to reconstruct the profile, right, or the state from the server. The server can remember that I am already logged in. And even if I refresh the screen, it should be able to recreate my identity. So what we're going to do is that, once I log in or sign up or whatnot, right, we're going to have that information on the server in the current user object, right? So if I refresh the screen, obviously locally in the reducer, that current user is going to be null. I mean, normally the way it would work is that if I log in, right, I set up the current user, if I find the person, and then I copy that in my reducer so that everybody else in any other page knows that I am currently logged in. But say I refresh the screen. If I refresh the screen, I would like to recreate the fact that I am logged in, right? Because we saw that, examples now that I was logged in, I refreshed the screen, and now my dashboard died, right? Because the current user was null now. So I would like to have a component that can recreate my state if I refresh my screen, right? To initiate and go back to the server and say, hey, server, was I logged in already? I don't remember, right? Because I just refreshed. And the server can respond to me, yep, you were logged in, and here's the current user. And we can do that by asking, what was our profile? Do we have a profile? So we can post to the server and say, okay, well, is there a profile? And the server can either return, yes, there's a current user, or no, there is no current user. Either case, right, we would like to update the local reducer, right, so whatever is stored in the reducer is up to date and in sync with the server. The server is going to now be the source of truth, right? Not the client anymore. The client is always going to be, some kind of stale copy of the real world being on the server. Okay, so the way we're going to do is that we're going to create a session component, right? That it's going to sit at the very top of our application, right under the provider. And what it's going to do is that it's going to initiate a request right away. The very first thing it's going to do, if you refresh, or it's one of the first components that will get rendered, and it's going to initiate a request out to the server, checking to see if there's a profile, and the profile will return. If we had just logged in, current user will be set. If we have not yet logged in, then current user will be null. But in any case, it'll come back and we'll copy that state, whether null or not. We'll copy it to our reducer so that our local state in the user interface, is up to date and in sync with the server. Make sense? So it's going to be something like this. We're going to have a session up here, right, run under the provider, right, that is going to surround the entire Kambaz application, right? If you remember, this is in the Kambaz layout. This contains the left side and the right side, the main content, right? So basically the entire application, but it needs to be under the provider, right? Because it does have to access the provider, setting the the current user and whatnot, right? And so the implementation is that it's going to keep track of a variable, right? The session can keep track of a variable on whether it's it's going to have a flag that is when once it loads, once it starts running, once the component starts rendering, it doesn't know yet, right? It's going to send out a request out to the server, but it doesn't really know the response just yet. Okay, and so it's going to have a pending flag saying, hey, the request went out, I don't know yet whether we're logged in or not. So we're going to have kind of like a loading timer saying, hey, I don't really know, I'm going to render loading, or if we are logged in, I'll render the rest of the component. So notice that the rest of the component here, the right side, the left side, right, everybody here is under the session body. See that? So this is passed into the session as children. So I either render the children, meaning the whole Kambaz application. Either I render my children, which is the whole Kambaz of it, or I'm going to render loading, meaning I don't know if I'm logged in yet, right? So I'm finding out yet, right? So So here's the implementation. So the session is going to go out when it renders. It's the very first thing that renders. No, because notice that it renders before it even gets to everything else, the left side or the right hand side. None of that, right? So it's going to initialize a flag pending to true, meaning pending means that I don't yet know whether I'm logged in or not. So I'm going to ask the server, but as of yet, I don't really know. Okay. And so what it does is that it's on load is going to call fetch profile. Okay. And fetch profile is going to go out to the server, it's going to make a post and out to the profile. It's going to do this right here, right? It's going to send a post profile like that. Okay. And and so when it comes back from the server, then I can know for sure, right, whether I'm logged in or not. So this object is either going to be null or an actual object, right? In either case, no error. In either case, it's not an error, right, that I'm logged in or not. I just want to know whether I'm logged in or not, right? So this is going to be null if I'm not logged in, or it's going to have an actual object if I'm logged in. And I'm just going to copy it into my local reducer so that the rest of the application knows whether I'm logged in or not. And then I can use that information. Once I know that I'm logged in or not, I can either push you to the login screen if you're not already logged in, or if you are already logged in, I can let you go to your profile directly, right? Or kick you out to the dashboard because now I know who you are. In any case, once I know that I'm logged in or not, right, I'm going to set my pending to false, meaning now I do know, right? I do know that whether I'm logged in or not. So I'm going to let the children pass by, and the children will know what to do whether I'm logged in or not, right? Because the account screen is going to check to see, right, if you're it's going to kick you out to the login screen or the profile. If you're already logged in, you're going to go to the profile. If you're not logged in, you're going to go to the sign in, right? So that's the children decide that. Okay. Now to talk to a server, we'll have to send a post to the profile, right? And then the server, right, is the only thing that's going to do is just basically my implementation of a profile is just returning, a reference to the current user that has been either set up by sign in or set up by sign up, right? Either one of them will have initialized my current user, so it's not null or not. Okay, so let's try it out. So let's create the profile here. Let's copy this. Now notice that the current implementation without the session, notice what happens, right? So if I go to sign in and to a legitimate person, so Ada, and I sign in, and then I go to my profile. Here's my profile. If I refresh, I lose my identity, right? Because my reducer is set to null. My current user, my reducer is set to null, so it kicks me out to the sign-in screen, right? So I don't have a profile. Right? Notice that I cannot navigate to the profile. But our intention is that if I can find out that, because the server knows that I'm still logged in, right? The server knows that I'm logged in because I just signed in. So the current user object is actually not null. So let's add on the server, this profile, so we could return the current profile, right? So we can survive a refresh. Right, so let's put that in here, profile. Oh, sorry, no, the server side. There we go. Profile. So we're going to respond with the current user object, this one right here. We'll respond with that. So, and then on the client side, we're going to make the post to go fetch that. And so here in the client, we're going to go fetch that profile. And we're going to do that in the session. So let's create session in the account. And oops, let's copy that. So on load, I'm going to go fetch the profile. And while it's pending, while I don't know, I'm not going to render anything. I'm just going to say, oh, I'm waiting for the server. Once I know, I'll let the rest of the application handle whether I'm logged in or not. Okay. And once I have that, I'm gonna wrap the entire application in the layout, the top level layout over here, right under the provider. We have the session like that. I'm going to import the session. There we go. Okay. All right. Yeah. So let's go back here and sign in this time around again. So Ada, sign in. Now, if we go to the profile, right, and notice if I refresh, notice that I am surviving my refresh. See that? Because what's happening is that every time I refresh, notice that the profile is going out. Right? We are going to back to the server to reestablish the state of the application so that now we know that the server is remembering that we are logged in. So that if I go to the dashboard, if you remember, when we refresh the dashboard, this was crashing. Now it doesn't crash, right? Because by the time we get to the dashboard, which is the children of the session has already decided on whether we're logged in or not, and the current user is appropriately configured. This time around, we are obviously logged in. So it recreates the profile, copies it locally in our current user. So this there's a defined user in the dashboard. Okay. All right. All right. So yeah. So we're going through each one of the various CRUD operations, right? When we are interacting with the data structure, we took a look at being able to create the user, or the create user when we're signing up, for instance. We also took a look at retrieving a user, either the profile, right, or right, finding them by username and whatnot. So we're going through the various CRUD operations. So it's CR to create, read, U for update, right? So we're going to do an update a user in the database. And the way it's going to work is that we want to be in the profile and fill out some fields that we don't have yet, right? We might have signed up, we filled in the username and password, and that's it. That's all we have, right? But certainly there are many other fields that we can update. Certainly our first name and last name, date of birth, email, blah blah blah, all that, right? So, but we want to do that on the server, right, so that it becomes permanent. Well, pseudo permanent, right? Until we don't have the database, this is not really going to be permanent. But we'll do that next lecture. So we're going to have an update button so that the update button is going to send a put request out to the server and providing encoding the ID of the user that we are updating as part of the URL. In the body is going to include all the updates, right? If we might have changed our email, our phone number, or something like that. And this is going to the route is going to use the update user DAO function that is going to just iterate over the users and recalculate the array, replacing that one user with a new version, right? And then it'll send back an OK back to the client, okay, if it's successful. All right, so on the DAO side, right? The DAO side, we are going to compute right over here in the you want to iterate over the array and replace right the current user. So we're going to iterate over all the users from the users, and if we find the user whose ID matches the one we're updating, we're just going to swap out the user. Okay. So yeah, so in the DAO for the users, the update it's already implemented. For the route, right, we are going to a put, an HTTP put with pointing to the URL users, encoding the ID of the user at the end of the URL following RESTful Web APIs convention, and we're going to extract the user ID. We're going to look up that particular user, and then tell the update user the ID of the user and the new updates that we retrieve from the body, right? And the DAO is going to update using the map that specific instance, and then we're going to find the user again, right, for that particular ID, and we're going to make that the current user, right? So that if we this works fine if it's me logging in and I'm modifying my information. I just want to make sure that the current user also has the latest information. So if I change the password, I want to make sure the password change also in the current user object. This doesn't work as much if you are talking about modifying any user, right? Any user ID, because if you're modifying, say I'm a system administrator and I'm modifying someone else, I don't want to use this function, right? Because this one is updating my current user, which is I'm an admin, has nothing to do with the user that I'm updating. So these would need to be separate, right? Yeah. So this is the route for updating. There it is. And we're going to be using this from the form, right? So we're going to have to be sending these put requests out from the profile form implemented here in the client, right? So there's the update. And in the profile page, right, we're going to bring in the client. And profile page. We're going to bring in the client, and we're going to have an event handler that we're going to call when we click on the update button. We're going to call this function that uses the client and copies the local state variable where we are displaying all our profile information, our username, password, first name, last name, all that is being displayed from the reducer, right? The current user that we get from the reducer. But this one's going to update it, right? It's going to go out to the server, it's going to update it, and then it's going to update also the local reducer with the current updates, right? With current user, so that they're in sync. The server's updated, the client is updated, and the rest of the application is updated. So we'll have a new update button below here. This one is sign out. So maybe for this one, we want this to be red. So this would be button danger. Whereas our new button here, maybe we'll make it button primary. Okay. Let's see. Also 100. It doesn't have to be 100. So yeah, so let's try it out. We'll account, sign in. Do we have a profile? No. Okay, sign in. So here's Ada, and we sign in. Here's the. We can go back to the profile. So it looks like we already have a first name and last name. And so let's try to change this. So we'll call this maybe Alice Wonderland, and we're gonna update. Okay, notice that goes out. Notice that the browser, making sure that it adheres to the course policy, making sure that it's not sending this request out, to a domain that should not be, right? Notice that it knows that we're running on port 3000, but the request is going out to 4000. So the browser is going out to the server saying, hey, what are my options? It's kind of like asking for permission. And it says, I know this comes from a different domain than you normally are, and the server is responding, hey, I'm wide open. You can do whatever you want. You can post, you can delete, you can put, you can get, and that's why there's a second request that goes out to put, right, the user information when we're sending my first name, last name, and so this should have updated in the server. If we refresh, yeah, we see that the information has been updated because I did update the current user, right? Otherwise, this wouldn't have worked. We would have gotten the old current user, right? That had the old first name and the old last name. Okay. So yeah, so that worked. How about logout? So logout, we want to kind of like invalidate the current user, letting everybody know that hey, there is no current user, and so we could do that from the profile, clicking on the sign out screen, and the sign out function locally in the profile can call a new sign out client function that's going to post to API user sign out. And in the router, right, we don't even need the DAO for this. We're just going to nullify our current user and just come back saying we were successful. And then in the client, we need to confirm, make sure that we we keep in sync with what the server is doing. So we're going to set the current user to null as well in the reducer. Okay. So in the server, what we're going to do is that we're going to when we receive a post to sign out, we're just going to make the current user null, and we're going to send back a status saying, "Yep, good, it's done. We've cleared out the current user." Let's post that in there and saying, "Yeah, we're good. It's 200, meaning okay." And on the client, we'll need to be able to send that post, right? Here in the client code, the sign out, there it is. And we're going to invoke this from the sign out button, right, in our page, right? So this is in the profile. We have a sign out button right now. The only thing, it's clearing it here, right? But it's not telling the server to do this, right? So we need to tell the server first, go out to the server, and then if everything goes good, we're going to clear it out locally, in our reducer, and then we're going to redirect you to sign in, right? So, if we do sign in with Ada, right, and then we go to our profile and we sign out, we indeed are navigated to the sign in. Okay. All right. All right. Let's talk about multiple sessions. So as you might have noticed, right, we only have one current user variable, right, in the server, and so that means that we're only ever having one single person logged in at any one time, right? But the more common realistic implementation is that a web application can handle any number of users, right? Allowing multiple users to be simultaneously logged in, and so being able to maintain a separate conversation with each one of them independently, right? So that maybe like Amazon, for instance, can keep track of everybody's shopping cart, right? So that it knows that you have a notebook and a pencil in your shopping cart, but someone else has a pen and a laptop, right, on their shopping cart. And even though it's conceptually it's one server, one application that is receiving requests from multiple users that could be dozens, hundreds, thousands, millions of users, right, hitting the same server, and the server needs to be able to maintain a conversation with all these folks, right? So how do we do that? Yeah, so to do that, and let me show you what the problem is, right? Notice that here, if I log in, so I log in as Ada, say, and I go sign in, and I go to my profile. Notice that if I open up a different browser, say Safari, and I go to localhost 3000, notice that the profile is there, right? So kind of showing me that I am logged in, even though I never logged in. Okay, so now I'm kind of logged in on both browsers because again, there's only really one server that is maintaining the same identity. So if I sign out on one of them, right? If I come here and I refresh, notice that I am also signed out here as well. And what we want to be able to do is have two users simultaneously logged in, independent of each other, right? And each one seeing their unique information, right? So to do that, we need to use cookies. Okay. Now, I don't know if you remember in the Matrix movie, when Neo goes to visit the Oracle, right? The Oracle offers Neo a cookie, and the Oracle won't even talk to Neo until until Neo accepts the cookie. So there's an example of what servers might do. Okay, servers follow a similar approach, right? When they talk to their clients, right? So here's a diagram that illustrates this mechanism. Here we have Alice, okay, that wants to talk to a server acme.com, okay? And it wants to do it in such a way that it wants to establish an identity, right? So that if Alice is talking to the server and Bob is talking to a server, we want the server to be able to distinguish between us. And now the problem with that is that HTTP as a protocol, as a technology, out of the box does not support this feature, right? All these requests going out to the server, to acme.com, from Alice, from Bob, from Dan, from Charlie, from anybody, right? There's no way for the server to distinguish one request from another. I mean, it could use the IP address, right? It would know that, hey, these are unique machines, but there's no API or there's no access visibility to that uses any of this, right? So as far as functionality is concerned, HTTP does not support multiple sessions. There's nothing that supports it. So in the early 90s, to fix this, Netscape was thinking about how to handle this. And so the solution was that what if the browser could send us a unique token to the server so that the server might be able to distinguish one browser from another browser, right? So that if browser provided a unique token, a cookie, right, it would be able to distinguish one browser from the other. Now, those cookies would have to be somewhat secure, right? The server would need to know to be able to distinguish them. So the way it would work is that the server itself would create these cookies, and the browsers would have to agree to store them on behalf of the server, and would have to agree that in subsequent queries, it would have to provide that cookie again back to the server, and the server would be able to distinguish and says, yes, this cookie, I know I created it, I know it's mine, and so I know it's you again, and then I'll let you in and do certain things, that we can continue a conversation because I know who you are, as opposed to Alice or Bob or Charlie. I can have different cookies for different conversations. Okay, so here's a mechanism how it works behind the scenes. We have Alice going out to acme.com, and it's her first time. She's never been to acme.com. And so what the browser does typically is that it checks to see in a cookie jar or a cookie store in the file system, right, in the local file system of where the browser is running, checks to see, hey, do I have a cookie for acme.com? Do I have a unique identifier for acme.com? If no, then, well, that's fine. The header, cookie header, out to the server will be empty. There won't be a cookie header. So when it gets to the server looks for any cookies in the header of the request, and it will find no cookies. So the server is going to assume, hey, this is the first time that this person has ever visited me. So what it will do is that it will create a new cookie, and the cookie is just a string. It's a name value pair, a name equal value. Now it has a an algorithm to make sure that uh, these unique identifiers are indeed unique, right? And also it's using an algorithm so that it knows that it was a server who created it. So that if you in the future provide me this cookie, I will for sure know that this is a cookie that I created. And what it'll do is that it will include this cookie in the response, right, in the header of the response. And so if the browser agrees to participate in this mechanism, the browser will store this cookie in the cookie jar, right, in the cookie store, right? So that for acme.com, so it knows that, oh, this cookie came from acme.com. So this means that next time around, we'll know, like, if it provides that same cookie, it'll know the same person. Now, along with that cookie, it creates a memory object, in-memory object, so it maintains a data structure that is mapped against that cookie. This is kind of like a hash table, right? It creates an object, a session object, and it maps it with it uses the identifier, the unique cookie as an index, right, to find that session object. Okay, so that next time around, if the same cookie comes around, I can look up that same session object with the key of that cookie. Okay, and so that data structure, right, is in itself a kind of like a hash table, where your programs, your application, your server application, right, all the routes that we've been working on, can store and retrieve data in there. Okay, based on that cookie, right? So that I can store data for Alice. I can store different data for Bob. I can store different information for Charlie, right? And I can remember what I stored because it'll be indexed, right? But the cookie, you give me the cookie, I'll know which conversation we're having, right? So next time around that you come, right, in your second request, this time around you will have a cookie for acme.com. And again, if you agree to participate in this mechanism, you will provide that cookie to me, in the header to the server. And so the server will check to see if the cookie hasn't timed out, right? If this cookie is not stale, right? That this is last month's cookie, that's fairly recent. Okay, then what it'll do is that it'll look up using the unique identifier as a key. It will look up the session object, right, and it will make it available to your application. It'll in the route, right, in your routes now you will have a new object, just like before you had the body object, right, when it's parsing the body of the HTTP request. Well, this is going to parse the cookie in the header. It will find the session object and it'll provide the session object to you, right, in the request. It'll be a new object called request.session, right, which will be a reference to that HTTP session, right? And there you can store data, you can set attributes to some value, you can update the data in there, and the cookie goes back to the browser, right, to make sure that it's stored, right? Also, it might update the date when it was last accessed, so they can keep track on how recent the cookie is, right? You can in a third call, right? Again, the cookie will go out, right? In the header, will retrieve the session object, and the application can retrieve the session object, and I can get data, so I can write to the session, I can read from the session, from my application, right? And and then respond with the cookie so that I reset the timeout. All right, so to be able to work with these cookies and the session, we're going to install a few libraries, right? In our case, will be the express session library. That's to work with cookies and sessions. We're not really going to work with cookies themselves. That's very low level. Instead, we're going to working with session objects. We're also going to need the .env library so that we can read environment variables, just like we did in the client, well, for our env files here as well. So let's install those express session first. So let's stop the server. Let's go to npm install express session, right? And also we'll need to install .env. So npm install .env, and then we'll restart the server. Okay. All right. So once we have those two libraries, we're going to create an env file with some environment variables that we're going to need. Right? In one case, we're going to need the environment variable that that will keep track of whether we are in production, we're in development, right? We are in a QA environment. What environment are we in? And depending on the environment, we'll set up the session differently, right? It will be slightly different depending on the environment. And also, we'll need URLs to so that we know who the client is that's going to be talking to us. So it's going to be sending requests, to make sure that we are making sure that we're talking only to the client, right, from our Versal or whatever. And we'll also need to know our own IP address, where are we running, also for security purposes. And finally, the cookies themselves we're gonna need to encrypt them to make sure that the cookies are not, that people don't steal cookies. I mean, they are stored in a local file in the browser, and so somebody, if you're using a your own laptop, it's not a problem. But if you're using a public laptop or a public machine, you might log in your bank account, and those cookies are stored in the browser on that machine. So if say you're logged in and you walk away, somebody could sit and steal some of the information by copying the file where all the cookies are stored. So we want to make sure that that cookie it's only valid on that machine, right? That if you copy it elsewhere, right, you cannot reestablish that identity. Okay, so yeah, so let's create an env file on our server. So here on our server, now it needs to be at the top level of our application folder. So there's .env, and let's copy these environment variables. Okay. Right. So now we have been using Course to make sure that we opened our communication with our browser client, but that was a little bit too open, right? We were allowing just anybody to talk to us, right? We're going to have to narrow that a little bit and say, well, actually, I don't want just anybody talking to me, right? I only want to be talking to my browser client that I wrote, that I know that I own, right? I only want to accept cookies and login information only from this particular URL, right? And so we're going to say, okay, well, I'm only accepting requests from client URL, where for us it's just HTTP localhost 3000 here on our local machine, right? That is the environment, right? There it is, localhost 3000. But when this gets deployed to Versal or render.com or AWS, right? This URL will be the Versal's URL, right? So this will be Versal, yada yada yada. So whatever your application is running on Versal, and this server would be whatever this is deployed on AWS. Okay, So we're making sure that only these two folks are talking to one another, right? So yeah, so let's also import the session and the .env, and so that we'll do that in our top level server file there, and course, right? And we're going to turn on credentials, meaning I'm going to expect cookies, authentication cookies, to come in the requests, right? So that I want to validate your identity, right? And I'm only accepting requests from that one origin and nowhere else, right? And then we're going to right after course, so right after course, but before on parsing, like right between here, okay, make sure that it's right between these two. We're going to configure our session, all right? Configure our session. And the session is going to be configured differently whether we are running locally on our machine or if we're running remotely, on render.com. Locally, this is all we need, right? We're going to set up a secret, just to encrypt our cookies. We want to recreate the cookie if it doesn't exist already. But if we are not local, we want to do some additional configuration, right? We'll make sure that proxy is true, meaning that usually the server you get on render.com or AWS, you're not talking directly to the server. Usually in between you have a balancing server, right? That's kind of like redirecting the requests out to, it's farming out your requests out to, one of dozens of machines that might be running simultaneously, kind of like balancing the load, so that, it'll find the machine that is least busy, right? And will redirect your requests to that. So you're not directly talking to the server. So there's a proxy in between. So, what you want to turn that on, right? And, also some safety information about, same site, and also making sure that it is running in the correct domain, so also for security purposes. So locally we only need this, but remotely, we'll add these additional session options, and then we instantiate the session configuration. So this is what is going to intercept all the requests that are coming in, all the gets, the posts, the puts, the delete. It's going to check to see if there's a cookie in the header, right? It's going to make, if there isn't, it'll create a new cookie. This will create the instance of the session object, and it will make the new session object available in the request. And then it'll let the request go through. Well, it'll continue the request so that all the other folks down here will have access to that request with that new session object, okay? And so let's see how is that we're going to use this session, okay? Okay, so how do we use this session? Well, we're going to have to rewrite a few things, right, on our login and sign up and all that, right? So our current implementation is using the current user, okay? But we saw the problem with that there's only one. So what we're going to do is that instead of using that one current user, we're just going to throw that out. Instead, it'll be, we're going to grab the current user we're going to create the object. And then once we create it, we're going to store it in this new session object, right? That is now available in the request. So again, this session object was created, right, by this right here, the use session, creates the session object and it makes it available in the request object. So it's now available here. And it's just it's a reference to a data structure that is it's indexed by the cookie, right? So that, if Alice comes in here, the cookie, this will create a session object for Alice, for her cookie. But if Bob comes in, he'll have a different cookie. So this will create a session object and for Bob, for his cookie. So now there will be two session objects. And the one that is made available here in the request, this session is pointing to the session object for either Alice or Bob, depending on what cookie came in through here, right? This one figures out from the header, parses the cookie from the header and says, oh, yes, I do have an object already instantiated for you, and it's indexed by this cookie, and it'll either be Alice's cookie or Bob's cookie. So here you will get either Alice's session or Bob's session, right? It'll be different. And then it's that data structure is kind of like a hash table that you can write to it. You can store anything in that data structure, in that hash table. So you can write to it by putting it on the left side, equal, and then the data you want to store in there, or you can read from it, and you can read from it like this. You can put it on the right-hand side and read from the session. So when do we want to write? We want to write, sign up. We want to write to it, to store the current user, so that next time around when we come in, we know that the current user is either null or not, right? And so sign up, we're going to rewrite it this way. And for the sign in, we're also going to rewrite it so that we'll check to see if there's a current user. We're going to store that current user and respond with it. Otherwise, we'll send an error, right, saying, oh, sorry, there is try logging in again. So yeah, so let's rebuild that. So sign up in the user routes. So sign up here, right? It's going to be DAO, create user, and there it is, a session current. And then sign in is going to be slightly different. So let me rewrite that sign in. There we go. And we're not going to have current user anymore. We're going to cancel that out. So anywhere where we had a current user, we're going to be using the session instead. So profile, same thing. Instead of using the current user object, this is a local instance where we read the session. And then whether it's, if it's not there, we send an error. But if not, we just send the current user. So let's update the profile implementation here. So here's the profile. Let's paste that in there. The resetting, right? If we sign out, we're going to destroy the session, right? Meaning we're going to invalidate that cookie. We're going to throw away the HTTP session object. So we're not going to remember anything about you anymore. And finally, the updating the session. When we update a user, we're also going to update the session object current user here as well. Okay. All right. Yeah. So that's on the server side. Now on the client side, also we do need to make a couple of changes. Now the current Axios library that we use, the default implementation, actually, out of the box, it doesn't use cookies. It does not include cookies in the header. Instead, you need to configure it, right? You need to turn it on by creating an instance of the Axios libraries with the credentials turned on to true, right? So let's do that. Let's revisit our account client. So on the browser side, right, we are going to create an Axios version that does include the cookies. And we're going to replace all our functions, right, to use this new version, okay, of Axios with credentials. I mean, they don't all need it. Well, all of these do, right, because they all have to do with identifying ourselves. But what I mean is that not all requests need identity, right? But these definitely do, okay? And so now, right, if we try to log in and say, Ada, and we log in, so there we are. So if I try Safari and I go to localhost, notice that I'm not logged in anymore, right? There's if I go to dashboard, it's going to crash because there's nobody logged in. Okay, And so if I just go to sign in, I can log in as someone else perhaps. Let's see, Iron Man, and let's see, so Stark 123, I think. Sign in. There we go. So now we're logged in as Iron Man here, whereas here we're logged in as Ada, right? And if I refresh Ada, right, I have her information, and if I log in here, if I refresh here, I have Iron Man. So now I can support any number of users, right? Ada, Iron Man, right? The Hulk. Okay, so I can have any number simultaneously logged in, and I can have a separate conversation from each one of them. Notice that the dashboard displays different courses. So Ada is enrolled in 3 courses, whereas Iron Man is enrolled in 2 different courses instead of 3. Right. So now the information is specific to each user. Okay. So now that we've been working on implementing the API for dealing with users, being able to log in, log out, sign up, profile. Let's now explore implementing other APIs to manipulate other data structures such as courses and modules. Okay. So as always, right, it'll always entail working with different files in either in the client or the server. Right? We first have to implement the DAO, right, the data access object functions that manipulate the data structures, right, in our case, courses. Then those operations need to be exposed and made available through an API to the web to create the web API. Then we need to create the client API on the browser side, right? And then finally the user interface that uses that API. So there's always 4 portions or 4 pieces that we need to manipulate. So first, let's start with the DAO and do something simple. Implement being able to retrieve all the courses, right, from our quote unquote database. So we'll implement the find all courses in the DAO. We'll create a courses DAO on the server. So just like we had a users DAO and a users routes, we're going to have a courses DAO and a courses route. And so we'll implement courses DAO, and then implement in here, we'll implement all the various CRUD operations. We're going to be able to create a course, retrieve the courses, update the courses, and delete the courses, right? So we'll start off with something simple as being able to retrieve all the courses, right? And the pattern here is that, right, we're going to implement all our functions that operate on the database, either reading from it or writing to the data structure. And then we're going to list all our functions in this map, this object here that is going to return, all the functions so that whoever instantiates us, right, are going to have access to all the functions that are declared inside of our DAO. Once we have that, right, we can have all several operations, several read operations, update operations, delete operations. Here's another one very common it will need. One allows us to retrieve all the courses, and another one that, for instance, allows us to retrieve only the courses for which we are enrolled. Right, so let's implement those 2. And as always, we'll need to list that function in the map here. So one of them just returns the whole array of courses, whereas this one filters the courses, from all the courses. It filters based on the enrollments, based on the user ID that you pass in. It says, well, give me the enrollment for that user. I'll give you the ID of the user, and it'll filter only the courses for which there is an enrollment that maps the user to the user ID and the course to the course ID as it iterates over all the courses. So it returns a subset of the courses for which you are enrolled. And so now we used to do this in the client. The client used to do all this filtering. But the proper thing to filter is, in the database, but we don't have a database just yet. Typically, this would be implemented as three tables, right? We have a users table, a courses table, and an enrollments table. And the enrollments table would have, two foreign keys. You have a user's foreign key and a courses foreign key. So you would have a where clause saying, select, users, courses, and enrollments where, enrollments user equals user ID and enrollment courses is equal to course ID, right? And so you would return a three-way join, with amongst those three tables. But here there's the equivalent, right? You have a couple of nested loops, iterating over the data structures, extracting the specific courses, subset of courses, right, where the enrollments and users match. Okay. So we're no longer going to filter in the user interface. We're going to remove the filter from the user interface because we are doing it already here on the server side, right? And next week, we'll do that in the database where it's the appropriate place to do it. Okay. So now that we have the the data manipulation code in the DAO, let's expose these operations through an API, a web API, right? In particular, let's start off with find all courses, right? So so let's implement a route here. And so this one is I'm exposing all the courses, again, following the naming convention, right? The RESTful conventions of prepending my web API with /API, and then using a plural noun, right? Where operating on that particular data set, right? And get means that I am reading from that. So I am retrieving all the courses. So and implemented by find all courses, which uses the DAO, to retrieve all the courses. And today it's using arrays. Next week we're going to start using collections or tables in a database, and then it just responds with that list of courses. Okay. And so we also want the expose the other axis, right? The other, retrieving courses for the enrolled users that we wrote here. Find courses for we'll also expose that as well. So let's copy that and let's paste it in here. All right, so both of them are available. In this case, if you provide me the ID of the user, I can give you the courses for that particular user. And now that ID could be for instance, for the person who's currently logged in. So if I'm already logged in, I should not have to provide the ID, right? Because the server already knows who's logged in. Okay, it's stored in the session. So I can access the data in a couple ways. I can give you an actual ID, or I can give you a token like current, meaning that, hey, you figure out who's logged in. If there's somebody logged in, then use that ID, right? And so if the ID I give you is current, then I'm going to retrieve the ID from the session, right? First of all, I'm going to check to see, well, if it's current, if you want the currently logged in user, if there's no one logged in, I'm going to give you a 401 error because no one is logged in. But if it's somebody's logged in, I can get the ID from the current user ID, right, and use that ID. Or if you give me an actual ID, right, it's not this case. I have the ID and it's already set in, if it's already set here, and I'm just going to retrieve the user, the courses for that enrolled user. So either way, right, I could just say, hey, figure out who's logged in, or if I'm a system administrator, I want to look at the enrolled courses for someone else. I'm logged in as a system administrator, but I want to know your courses. I'll use your ID to retrieve your course. So this function is smart enough to know whether it's mine or someone else's. Okay. So now that we have that exposed, we should be able to retrieve that. If we go to localhost 4000 and we say API courses, well, I should retrieve all the courses. Oh yeah, no, we never loaded this into the index, right? So let's import the courses. There we go. And we are going to invoke the courses with the database. And let's try that again. There we go. So here are the courses. And I can ask Ada. Ada, I think she is 777. So it would be users 777 courses. And so this would be the 3 courses that she's enrolled in. Okay. And I think 123 is yeah, that's Ironman, right? So he's enrolled in these 2 courses. And current would not work because I'm not logged in. So current, that would fail, unauthorized. Now, although if I do log in, let's say I log in and sign out and I log in as Ada, notice that before, if I say current, this fails, right? Current fails. But if I do log in as Ada, actually, okay, that's not going to put me in the session, is it? Yeah, okay, here I'm in the session, but here, oh, there we go. Yeah, there is a session set up. I can retrieve the ID from the currently logged in user, so it works, perfect, okay. Now, obviously, we want to do that programmatically from the user interface. So instead of doing that, like we did, we were just trying it out. Let's create a client so that we can talk to those APIs programmatically. And we can do that here. Maybe we could do it under the courses client. We can, for instance, retrieve all courses, or we can retrieve the courses that you're currently logged in. So let's copy that. We'll bring in the local host 4000, right? The base API, it'll be localhost 4000 API courses. That's exactly what we've been using here, right? To try it out. This one, like that. To retrieve all the courses, right? So that's the API for that. So fetching all the courses. And then in if I want to retrieve my courses, right, I can again use the token current. But for that one, I'll need a credential. So for retrieving all the courses, I don't need the credentials, right? I'm just retrieving all the courses, regardless who's logged in. But if I want to know my courses, then yes, I need to use one that has credentials, right? So yeah, let's create a version of Axios that is using cookies. And the base URL for that is API users, right? For all courses, I don't need credentials, so I'm not going to change that. But for retrieving my courses, I do need to use Axios with credentials, like that. Okay, there we go. Yeah, so once we have that, we can go back to the reducer, and we no longer want to use the local database in the reducer, right? So we're going to just start off with an empty array. But that brings on the question of, if I don't have this set up, right? If I don't have any courses from the database, then how am I ever going to populate this? Well, the way we're going to populate it is that we're going to create a new set courses function here that we are going to call. We're going to make it available in the API here, right? In the export. Is that, hey, the server has all that information. We have to go fetch it, okay? And I mean, we do have APIs for that, right? We just tried it out, between the courses. So what we're gonna do is that the user interface, right? The React components that are, like the dashboard and the courses page are the ones who are going to initiate the communication with the server to fetch all this information. We're just going to have to, that once we have that data in the user interface, we're just going to have to populate here in the reducer, so that as we move around from one page to the next, right, we'll have a local cache or a local copy of that information here. Okay. All right, so let's do that, right? So we initialize it as empty. We have the set courses. So in the dashboard, when we first come in, we know who the current user is, right? We, and the enrollments, where all that is on the server, and we want to get rid of all uses of the local database, right? We should be able to fetch these courses from here. We should be able to initiate the request using our brand new client, right? In the dashboard. In the dashboard, right, we should be able to not have to use the database anymore, and we should not need the enrollments anymore, right? Because we're not even going to filter locally, right? All this filtering, all this is being done in the on the server. The server's doing all that, right? So we don't need that anymore. The courses, when it gets to us in the front end, it'll already be filtered by the server. The server has already done all that enrollment stuff. Okay, so the courses that we get here in the user interface have already been pre-processed. Okay, although we do have to initiate the request that goes out to the server, and then make sure that we notify our reducer with all the new courses that we get from the server. Okay, so that it'll be available globally through the application. So yeah, so on load, when we first load, right, we are going to the client. What happened to the client? Did we not load the client? Import client. There we go. So on load, we're going to fetch the courses. We say fetch the courses from client, find my courses, and we're going to notify the reducer. Hey, here are the courses, so that it's globally known what my courses are. So if I start navigating to the courses page and whatnot, right, I have that course stored in the reducer. Okay. Let's see. So let's try it out. If I go here and I navigate back, right, to here, and I inspect, we could see what the communication looks like. Right, we can look at network. So as I log in, as say Ada, I log in. Okay, notice that in navigating to the dashboard, I have my 3 courses, but these courses are no longer from the reducer. They're coming from the server. See that? These are the courses that come back. These are the 3 courses for Ada. And it's been notifying the reducer. Okay, awesome. How about creating new courses? And we need to, for each one of our CRUD operations, we need to implement the DAO, right, that actually manipulates the data structure. Then we have to implement the route to expose this to the web API. Then we need to implement the web API clients so that we can send the post, the put, the gets, and whatnot from the browser. And then finally, in the user interface, is going to use that web API client. So to create a course, the user interface is going to have a form where you can fill out the new course, right? You're going to provide the title, the description. So when you submit that, that's going to make its way here in the DAO, and all that new title and new description, I'm going to use that for from the form, but I'm going to create a primary key here on the server. It's typically we create these primary keys on the server or even in the database, right? Not in the user interface like we were doing earlier. But that was because we didn't have a database just yet. Okay. So yeah, so let's create a course which is manipulates the data structure by appending a new course. So let's put it up here. There it is. So create. It's going to just create a new one and then push it at the end of the array. And we're going to oh wait, no, that's in the DAL. Sorry, in the DAL, and we're creating a new course. There you go. And we are going to expose that function right here. So create course, perfect. Then we're going to make that function available in the URL. Now we are, when we create a new course, actually we need to keep track of a couple of things. In particular, for the creator of the course. If you create the course, right now, if you know, when you are reading your courses in your API here in your user interface, these courses are the ones that you are enrolled in. So if I create a new course, then if I'm not enrolled in it, I would never see the course that I just created. So either a faculty can enroll themselves, uh, or a student can enroll in a course without creating a course. So there's several mechanisms by which you can enroll. Certainly, you are asked to implement the enrollment from a student's point of view, but from a faculty's point of view, right? It should be the case that when you create a brand new course, you should be automatically enrolled in it, right? So you see your new creation right away. Okay? So, and these are two different data structures, right? The courses is one array stored in presumably in a particular collection, in a particular table. Enrollments too. Enrollments is also its own data structure, right? We also need to be able to create new enrollments, delete enrollments, modify an enrollment, right? So it's it needs its own DAO, right? That does all the CRUD operations for enrollments, right? So let's create that. And in here we can have functions such as enroll users in our course, unenroll a user, or giving a user give me all the courses they enrolled in, or giving a course give me all the users enrolled in that course. So there's quite a few operations that we can ask from the enrollments point of view, right? So now what we can do is that in the route for creating a new course, we can use two different DAOs. One that actually creates the course, and then another DAO that enrolls that user in that course, right? So let's do that. So in the courses route, we're going to need both DAOs. We'll need the course DAO and the enrollment DAO passed using the same database, right? Using the same database. So that when you create a new course, right? When you create a new course, not only are you going to create it using the course DAO, but you're also going to enroll the person in that course. Okay. All right. So yeah. So let's add that to our route. Also important to note here is that when we create the course, notice that we respond only with that new course, right? Not like we did when we were working with to-dos. If you remember, we were responding with the entire array of to-dos, and and uh, and and um and then we discussed that a better approach would be that you would only return that one single instance you just created. Otherwise, it would be very expensive, right? To have to respond with the entire array, even though you only have just one new item. Also because the front end already has a cached copy of this data structure. It's already there. The user interface already has the fact that you have these three courses, right? There's no need for you to send me back the whole array because I already have three of them. You just need to tell me what the new one is, right? And we have to make sure that that the client array here in the browser is in sync with the array that is on the server. right? So you have to make sure that, if the server fails to create something, that I don't inadvertently create it on the front end. I don't want to falsely show something in the user interface that's not true, right? If the server wasn't able to create it, I should not display it on the front end, and vice versa. They should be always in sync. So here's the server, after having successfully created a new course, is responding with that, and the browser, the client side needs to make sure that that new course is added to the new array. So in the courses client, create a new course, right? So we have here a couple of read operations. This time around, we're going to create a new course for the current user, and so they can find out who the current user is. Current user, well, actually, it's ignoring it. It's always using only the current user can create a course, right? Other few things here that you might want to make sure of is that not just any user can create a course, right? So typically, when the current user, you want to make sure that they are in the correct role, right? Only an admin user or faculty could create a course, but if you're a student, you should not be able to create a course. We're not doing any of those validations, but certainly it would be appropriate, right? So that sends out the course to be created. Now on the client side, right? The add button, okay, we're going to handle the add button so that it goes out to the server first to fetch the new course that's been created, and that new course is then appended to the array of courses that we have using our new set courses, right? So let's do that. In the dashboard, right? We are going to have a button that we're going to click on to call on add new course. So here's the add. Instead of calling add new course, right, we're going to handle this right here. We're going to say on add new course. We're going to go out to the server and then tell the dispatcher, the reducer, how we want to modify our data structure locally. Okay, so let's try it out. Let's see. So we're here. We need to log in. We're going to sign out, Ada. And so sign in. And so let's create here, rocket or aerodynamics, spacecraft design, space station design. And so this is the new description. So we're going to add. Now it'd be interesting to see and inspect the request that goes out on network. We'd be able to see that. So if we say add, yeah, they went out, right? Here's our post. You can see the data that we're sending there, right, with the description and the title. And the response is a new object with a new primary key, and it has been appended at the end. See that? All right. All right, how about deleting a course? So deleting a course, right? Not only are we going to recompute the array of courses, so we're going to filter out the course we want to remove, but should also filter out from the enrollments, right? The fact that you were enrolled in that course, right? We're going to remove that enrollment so that you no longer are enrolled in that course. That enrollment goes away. Now, if you're removing the course, that means that if you have tons of students already enrolled in that course, all those enrollments go away, right? It could not be that I'm enrolled I'm not enrolled because it was removed, but you are enrolled. It makes no sense, right? So let's copy that, and on the server side, in the DAO of the courses, we can implement our new delete course, and then in the route, right, we can expose that. Oops, what is it complaining about? Function. Right? Wait a minute. Uh, Here, is that? Oh, yeah. Just copy delete course. What's wrong? Yeah, let's paste that. Delete course. Oh, it's missing a curly bracket here. Okay, I see. And then we're going to add delete course at the end here. Or perfect. Yeah. Then we're going to expose that in the routes. Right. So in the routes, we're going to pass in the ID of the course that we want to remove. So again, following the RESTful API conventions, right? We're using delete HTTP method, right? We are encoding the ID in the path, right? We're using the plural nouns, right? No verbs in the paths, right? And so we use the course ID to pass it to our DAO to filter out. And also notice that we're not returning the array of the objects that survived, right? Instead, we're just going to respond saying whether we were successful or not, right? And that would be in the status, right? Now, when we get to the database next lecture, right? This is an object that's going to come back from the database, right? Which is going to say whether we were successful deleting it or not, right? And so we can handle those errors appropriately. So yeah, so now we can delete that from the user interface. We can copy, we can implement the client web API, right? So that we can send in our request to remove that one course, and then from the user interface, we can call that client, right? When we click on the delete button on each one of the courses, and then once we know that that course has been removed, we can filter it out from our local state variable, right? And so in the dashboard, right, we can implement on delete, right? If we give it the ID of the course, we can filter it out, right? I guess this is any, and we're going to call the delete button, right, on the on that course. So we have a delete somewhere here. Here's delete. So we're not going to directly go to the dispatcher. We're going to first go out to the server. It goes out to the server, and then we're going to tell the dispatcher of the new state. Okay. So let's try it out. Let's see. We might need to log out, and let's go to Ada. Sign in, and we can see the inspector to see if we can remove something. So network. So let's say we remove aerodynamics. If you click on that, notice that the delete went out, right? Localhost course RS102 delete, right? And the response is oh, we didn't respond with an okay. We should have responded with an okay. We'll fix that next week, next lecture when we looked at the database. But nevertheless, we were able to filter it out. Okay. All right. How about updating a course? So to update a course, we're just going to replace a course. You're going to send us a course update, and we're basically just going to swap out the course when we find it by its own ID. Again, same thing that we would do on the front end, but we're doing it by modifying data structures on the back end, right? So on our DAO, right, we're going to update that and make that new function available in the map, the API, so that in the routes, right, we can call that new update, right, when we send in a put, again, following RESTful web APIs conventions, right? For modifying, we use put, we encode the ID in the URL. We use our nouns, no verbs, right? And so we parse out the course ID, we pass it, the new updates are going to be in the body. So any new, any new title, any changes to the description will come in through here. We pass them up to the update course, we're gonna swap it out on the array, right? It's gonna have a status. Then on the client side, right, we need to be able to call that that API, right? We're gonna send a put, including the ID at the end, and so that here in the API, in the client, we're gonna pass in the course object where we get the ID and send the updates. Okay. In the user interface, right, we're going to click on the edit button to make the changes, and then in the save button to send the updates. And we'll send the updates to the server, and the server will come back and then make those changes as well locally, right, on our user interface. Again, making sure that these are in sync. All right. So in the dashboard, right, here's a event handler for updating the course, right, first on the server. If we're successful, we're making the changes locally as well. And we do that by sending a request to when we click on the update button, right, which is this one, right? So so we're going to call the update. Oops. The, click that. There we go. So let's try it out. So first we'll go to Ada, navigate to Ada, sign in, and if we edit, right, we should be able to see inspect here, see the network, so that if I click on edit here, it gets copied to the local form, and we can make some really trivial changes here. And then clicking on update, there we go, right? So it goes out to the server. The server, we send out a put, right, with the the new description, right, the new title, the new name, right, and then when it gets back to the client, we make the change also in the user interface. All right. All right. Yeah, that's all I have for you today. If you could work through the exercises in the book, right, and create the APIs for courses, for users, for modules, and the book walks you through implementing all those, and then on your own, you would implement the assignments, right, to be able to again do all the CRUD operations on assignments, create assignments, delete assignments, update assignments,